Hey there, fellow deep divers. Ready to get the heart of a complex topic. Today we're diving into something that's often oversimplified, leaving science.
It really is. We hear that narrative about women leaving science more often than men, and while there's some truth there, it's just the very beginning on a much bigger picture.
Oh, I love it when a simple story turns out to be way more complicated. So let's dig in. We're taking a look at a research paper called Quantifying Attrition in Science by Professor Marek Kwiek.
And what makes this research really stand out is that Kwiek and his team took this big data approach, looking at millions of scientists' careers over time.
Okay, hold on. Millions. That's a crazy amount of data. I'm definitely intrigued. Where did they even get all that information from?
They used data from Scopus. It's this huge database that tracks all kinds of academic publications.
Ah, so like a global record of who's publishing what and when.
Exactly. And by looking at that data, Kwiek's team was able to track scientists across 38 different OECD countries, the Organization for Economic Cooperation and Development.
38 countries. Wow. That's a pretty global perspective. So we're not just talking about like scientists in the US or Europe. This is the big picture stuff.
It really is. And we're talking about a ton of different STEM fields, too. Science, technology, engineering, mathematics, and medicine.
Okay, so we've got millions of scientists from all over the world across tons of fields. This is already shaping up to be a fascinating deep dive. But I have a question. When we talk about leaving science, what exactly does that mean in this context?
So in this study, they define it as ceasing to publish in those academic journals.
I see. So someone might still be involved in science in other ways, but if they're not publishing in those journals, they're considered to have left for the purposes of this research.
You got it. It's like, imagine a relay race. We're focusing on one particular leg of that race. Doesn't mean the runner has disappeared. They might be doing other important things, just not on that specific leg at that moment.
I like that. Makes it clear that a scientist's path isn't always a straight line.
Right. There are all sorts of twists and turns along the way, and the research really digs into that, using something called survival analysis, basically, calculating the odds of a scientific career surviving, meaning continuing to publish at different points.
Okay, so it's like those survival rates you see in like nature documentaries. Like, what are the chances a baby turtle will make it to adulthood?
It is, and it helps us understand at what points in their careers are scientists most likely to stop publishing.
Fascinating. Okay, so before we started, you mentioned this research challenges the common narrative about women leaving science. What did they actually find?
Here's where things get really interesting. For scientists who started publishing around 2000, there was a pretty noticeable gender gap in those survival rates. Women were more likely to stop publishing than men.
So that supports the usual story we hear. Okay.
Yeah.
But I have a feeling there's a twist coming.
You bet there is. They found that for scientists who began publishing around 2010, that gap significantly shrank.
Really? So the gap's actually closing.
Exactly. For those scientists starting out a decade later, the difference in those survival rates between men and women, it nearly vanished.
Wow. Okay. That is a big deal. Any clues as to why that might be?
Well, the research doesn't give us all the answers, but it does get us thinking. Were working conditions different for those who started in 2010? Did societal expectations change? Did universities start doing things differently? All things to consider.
It really makes you wonder, did those later cohorts of scientists experience a totally different landscape? Like maybe there were more opportunities for mentorship or better work-life balance initiatives?
It's definitely possible. But here's the thing. The overall picture, it can be kind of deceiving.
Oh, how so?
When we zoom in on individual scientific fields, the story gets even more interesting.
Oh, I love when that happens. So tell me, what do we see when we start breaking things down?
Well, for example, take biochemistry. They found higher attrition rates for women in that field, especially after 5 and 10 years of publishing.
So even though the overall gap might be shrinking, certain areas are still seeing those trends.
Exactly. But then if we look at physics and astronomy, fields often seen as male-dominated, there's practically no gender difference in attrition rates.
Wait, really? So it's like these math-heavy fields are bucking the trend.
They really are. Makes you wonder what might be going on in those fields specifically.
It does. Why would those fields be different?
Well, that's something we'll definitely need to explore further.
So we've got these fascinating differences between fields. But why? Why would those math-heavy fields like physics and astronomy show almost no gender difference in attrition?
Well, it's a question that sparked a lot of debate, and there isn't one clear-cut answer. One idea that's been tossed around is this concept of proportional scarcity.
Proportional scarcity. Okay, I'm not familiar with that one. Break it down for me.
So think about it this way. If you're a woman entering a field where there are already fewer women, you might face more scrutiny, right? But you also might be incredibly driven to succeed.
So it's like you've already overcome so many hurdles just to get there that leaving doesn't even cross your mind. You're part of this smaller group that's extra motivated to prove themselves.
Exactly. And that resilience, that drive to excel it, might actually contribute to those lower attrition rates we're seeing.
Okay, that makes sense.
Yeah.
But it's probably not the whole story, right? There could be other factors at play too.
Oh, absolutely. For example, it's possible that the leakiest points for women in those fields happen even earlier, like maybe during the transition from high school to university.
So if fewer women are choosing to study physics in the first place, that could explain why the attrition rates later on look similar for men and women.
Right. It's like the pool of potential scientists is already skewed, and that's a whole other issue that needs attention. But even if those early choices are a factor, it doesn't diminish the potential impact of proportional scarcity later on.
Right. It's likely a combination of factors, all feeding into this complex puzzle.
Exactly. And to make things even more nuanced, we also have to consider the research system in each country, which can vary drastically.
So even if two scientists are both physicists, their experiences could be vastly different depending on where they're based.
You got it. Some countries might have a really strong pull from industry, which could lure scientists away from those academic positions, regardless of gender.
So it's like there's this whole ecosystem surrounding science, shaped by so many forces, gender, discipline, national context. It's a lot to keep track of.
It is, and that's what makes this research so important. It's pushing us to think beyond those simple explanations and to grapple with the true complexity of this issue.
Absolutely. It's a call for more nuanced solutions too, right?
Yeah.
Recognizing that what works in one context might not be effective in another.
Exactly. But even with all this complexity, there's one finding from this research that I found kind of sobering.
Oh, what's that?
Even in that 2010 cohort where we saw the gender gap shrinking, over 60% of scientists stopped publishing within 10 years of starting their careers.
Wow, that's a lot. So it's not just about gender, it's a lot of talented people, period, choosing to leave science.
It is. Makes you wonder what factors are driving those decisions beyond just gender.
It does.
Yeah.
I mean, what are some of those broader forces that might be pushing people away from science?
Well, the increasing competition for those academic jobs is a big one. That pressure to publish frequently to get those grants, it can be pretty intense.
Yeah, I can imagine that takes a toll both mentally and emotionally.
It does. And then there's that age-old struggle with work-life balance, which is an issue across so many fields, not just science.
It's like this whole system of pressures and expectations that can make it really tough to stay in science long term.
It is. And it's something we need to talk more about, how to create a culture of science that's more sustainable and supportive for everyone.
Absolutely. Okay, well, I think we've established that leading science isn't just about one simple story. It's a whole web of interconnected factors, all influencing who stays and who goes.
Exactly. And this research, it's pushing us to unravel that web and to really understand the forces at play.
It is. But I'm also curious about something else you mentioned earlier. Professor Kwiek's team didn't just focus on who leaves science. They also look at publishing frequency, right? Like how often scientists are putting out those research papers.
You got it. They dug into those publishing patterns and they found some interesting trends.
Like what? Spill the tea.
Well, for starters, they found that about 90% of the scientists in that 2000 cohort published at least one article every year.
Wow, that's pretty consistent. So it's not like everyone's disappearing from the publishing scene altogether.
Right. Most scientists are managing to stay active, at least to some degree. But they also looked at publishing breaks periods when a scientist might pause their publishing activities.
Okay, that makes sense. I mean, life happens. People take breaks for all sorts of reasons. But I'm curious, were they able to pinpoint any patterns in those breaks? Like, are there certain career stages where it's more common for scientists to step back from publishing?
That's exactly what they were looking for. And remember, they were looking at medians, so it's like a general overview, not about specific individuals. But it's still insightful. They found that 60% of women and 55% of men took no breaks at all during a 12-year period.
Wow, that's dedication. But I bet there are some scientists who take those longer breaks for a variety of reasons.
For sure. It could be anything from taking on a new leadership role to dealing with family matters to simply shifting their research focus in a way that doesn't immediately lead to publications.
Right, it's like they're exploring a new scientific landscape, and it takes time to gather those publishable results.
Exactly. It's a good reminder that a scientist's career isn't always this perfectly linear path. There are all sorts of twists and turns along the way.
Absolutely. Okay, so we've talked about those publishing breaks, but I'm also remembering that Professor Kwiek's team used these things called Kaplan-Meier curves to visualize some of those trends. Now, to be honest, I'm not a statistician, so can you break down those curves for me? Like, what are they and why are they so helpful for understanding this research?
Okay, so imagine you're watching a marathon, right? And you want to track how many runners are still in the race at different points along the course.
Okay, I'm with you so far. I love a good marathon analogy.
Perfect. Well, that's essentially what a Kaplan-Meier curve does, but for scientific careers, it shows you the percentage of scientists who are still actively publishing over time.
Ah, I see. So if the line on that graph starts to take a nosedive, it means a lot of scientists are dropping out of the publishing marathon at that point.
Exactly. And the shape of those curves can tell us a lot about when and how that attrition is happening.
Ooh, this is getting good. So what did those curves reveal about the trends we've been discussing?
Well, for example, if we look at that 2000 cohort, the curve for women is steeper than the curve for men, especially in those early years after they published their first paper.
Right, which lines up with that finding that women in that cohort were more likely to stop publishing early in their careers.
Exactly. It's like we're seeing those trends play out visually, which can be really powerful.
It is. But I also remember that we saw the gender gap basically disappear for that 2010 cohort. Does that show up in the Kaplan-Meier curves too?
Yes, it does. For the 2010 cohort, those curves for men and women are much closer together, meaning their attrition rates are more similar. It's like they're running side by side in that publishing marathon.
That's such a cool way to see it. Okay, so those curves are definitely helpful for seeing the overall trends, but we also talked about those important differences between scientific fields. Do those curves reflect those nuances as well?
They do. When we zoom in and look at those curves for specific fields, those differences really jump out. For example, in biochemistry, the gap between those curves for men and women is still noticeable, even for that 2010 cohort.
So even though the overall trend might be positive, some areas are still lagging behind when it comes to retaining women.
Unfortunately, yes. It really highlights the need for those targeted solutions, recognizing that what works in one field might not work in another.
It's about understanding the unique challenges and dynamics of each scientific community.
Exactly. And it's not just about gender and discipline either. Remember, Professor Kwiek's research also emphasized the role of national context.
Oh, right. The scientific ecosystem in one country can look totally different from another. Can you elaborate on that a bit more?
Sure. So, a scientist in the U.S. might face a completely different set of pressures and opportunities compared to a scientist in, say, Germany or Japan.
It's almost like there are multiple scientific universes out there, each with its own gravitational pull.
That's a great way to put it. And navigating those different universes can definitely impact a scientist's career trajectory.
So it's not just about individual choices. It's about recognizing that those choices are often shaped by forces beyond a scientist's control.
Exactly. It's about understanding those larger systemic factors that are influencing who stays in science and who decides to pursue a different path.
You know, as we've been talking about all these trends and factors, it's easy to get lost in the weeds, but I keep coming back to this one question. What does all of this tell us about the overall health and vitality of science itself?
It's a question that really gets to the heart of it all, doesn't it? Like, if we zoom out from those individual stories and career paths, what does this research say about the big picture?
Exactly. Are we doing enough to cultivate and nurture scientific talent? Are we creating environments where those brilliant minds can thrive?
It makes you think, right? Especially when we see that over 60% of researchers are leaving the field within a decade. It's a pretty significant loss of potential.
It is. And, you know, it's not just about those numbers on a spreadsheet. It's about the very future of scientific progress.
Right. We're facing some pretty massive global challenges right now. Climate change, pandemics, resource scarcity. We need science more than ever to help us navigate all of that.
We do. And to do that effectively, we need a scientific workforce that's not just brilliant, but also diverse, resilient, and supported.
Absolutely. We can't afford to lose those bright minds because the system isn't working for them.
It's a call to action for everyone who cares about science. Policymakers, educators, industry leaders, we all have a role to play in creating those supportive and thriving scientific communities.
I couldn't agree more. It's about fostering a culture of mentorship and collaboration where scientists feel valued and empowered to pursue their research passions.
Exactly. And that brings us back to you, our listener. Does this research change how you see science as a career? What factors would matter most to UA in deciding whether to stay in science or explore a different path?
What are your non-negotiables? Is it a supportive work environment? Is it the freedom to pursue groundbreaking discoveries no matter the challenges?
Those are some big questions worth pondering, especially if you're at a crossroads in your own scientific journey.
And if you're ready to dive deeper into the data and explore those trends in your field of interest, I highly recommend checking out Professor Kwiek's interactive attrition dashboard.
Yes, it's a fantastic resource for seeing how those patterns play out in different contexts. You can find a link to the dashboard on Professor Kwiek's website, or just do a quick Google search for Marek Kwiek Attrition Dashboard.
It's an amazing tool. It
Oh.
really puts the power of data analysis right at your fingertips.
It does. And with that, I think we've reached the end of our deep dive into leaving science.
We've covered a lot of ground today, haven't we? Debunking myths, grappling with complex data, and even contemplating the future of science itself.
We have. It's been an incredible journey, and we hope it sparked some new thoughts and questions for you, our listener.
As always, we encourage you to keep exploring, keep questioning, and keep diving deep into those topics that ignite your curiosity.
Because that's what the deep dive is all about, empowering you with knowledge, insights, and a healthy dose of wonder.
So until next time, keep those minds engaged and those explorations going.
Happy diving.